Hi friends, in this video we solve supermesh based KVL equations, right? So first we must know what is supermesh, then only we can understand the problems given in this video. So supermesh definition is, write properly, supermesh results, when it occurs, it results when two meshes have common current source. Two meshes have common current. Okay, so that is the first thing we have to remember. So let us solve the question based on this condition. So you see in this problem we have this mesh 1, this is mesh 2. Let us assume the current flows through this meshes I1. Here the current flows through this meshes I2. Here you see we have two meshes. In between two meshes we have a common current source 5 ampere. So these two meshes form super nodes. Okay, so this is a super node problem. So we have to use super mesh analysis problem. Okay, fine. So how we are going to write KVL equations for the given circuit? Whenever we have a mesh with super mesh, the procedure we have to follow is as per the discussion we are going to have now, right? Okay, so first what we have to do, so this is mesh 1, mesh 2, we have a super mesh. So whenever we have a super mesh, first what we have to do is just ignore this initial this branch which is common to both the meshes. We write a KVL for this one. Fine. This branch you just forget it. Okay, first what we are going to write here, we write KVL for this mesh. This is called a super mesh. So here what is the current flowing through this resistor? I1, and R is 1, so it is I1. Then comes here it is current flowing through this resistor is I2, R is 3, so 3I2. Here current is I2, R is 4, so 4I2. Come here, and here you see current enters to negative terminal, so it is minus 10 is equal to 0. This is equation. Now what we have to do, we have to write KCL for this branch. Okay, what is the branch? This is the branch. So that is what this one, for this branch we have to write KCL. Here 5 amperes flows. What is the current coming here? I2, so it is I2. Here it is I1. Fine. So this indicates I2, the incoming current is equal to two outgoing currents, 5 plus I1. Right? So now we have two equations. 1, 2. You see, we have two variable I1 and I2. We have two equations, so we can solve this problem. In this way, we have to write the KVL equations for supermesh circuits, the circuits with the supermesh. No, right? Okay. Now let me give one more example. Here we have three meshes, and this current is 5 ampere current, right? Okay. Now you see here we have this is mesh 1, mesh 2, mesh 3. We have current source common between two meshes, so this comes under the category of super mesh. So first what we have to do, first we mark the current. Let us assume this is mesh 1. Okay, this is mesh 2. The current I take always positive direction. You can take any direction. I2. Then this is I3. Okay, so here what is the current coming? Because this is a branch common to both meshes, so I can consider this is super mesh branch. So here current entering is I2, here current leaving is I1. So that is very important, right? Okay, now we write a KVL for, see where is the super mesh? So we can see the super mesh We start from here. This current source is common to mesh 1 and 2. So this mesh 1 and 2 forms super mesh. So mesh 1 and 2 form super mesh. So how we are going to do? So this is the super mesh. So now we write KVL for super mesh. So KVL for super mesh. We start from here. So here what is the current flowing? This is I1. So 4 into I1. Here the current is I1. Here the current opposite current is I3. So 1 into I1 minus I3. Again you come here, just ignore this super mesh branch now. Later we will see. So here the current going through this is I2, because here in this branch, in this mesh, the current is I2. Opposite current is I3. So plus 3 I2 minus I3. Here next what we have, okay, this 6 volt, please forgive me, it is not this one. Here that direction is like this, 6 volt. Okay, so plus 6, current enters to positive terminal, so plus. This is what the KVL for super mesh. So now we have to write KCL for super mesh branch. Here what is branch? It is like this. Fine. Here the current enter is I2. Here the current leaving is I1. This is 5 ampere. So I2 is equal to I1 plus 5. So this is equation number 1. Equation number 2. Now we finish with these two. What is the remaining one mesh? I3. So KVL for I3 is super mesh 3. What is that? Here, let us start from here. This is what you call 7 volt, right? So 7 volt. First I write 7 volt. Then here I3 is coming, I2 is coming opposite side. So 7 volt plus, in this branch the current is I3 is coming in this side, I2 is coming opposite side. So 3 into I3 minus I2. Next this branch here, the current is I3 because we are bothering about mesh 3. So current is I3 here, I1 is coming opposite. So plus 1 I3 minus I1. Okay, next this is the 2I1, so 2I3. The current flowing through that mesh is 2I3. That is equal to 0. This indicates this is minus I1. I2, how many I2? Only 3 I2 is that. So minus 3 I2 plus 2 plus 3 plus 6 I3 plus 7 is equal to 0. Now you see we have 3 variable I1, I2, I3 and 3 equation. This is 2, right? So third equation. So 3 variable 3 equation, we can solve the problem. Fine. As per the system of linear equation, we can solve this problem. Okay, later we will do that. First we write equation. So for this I have to write KVL equation. So what we have to do, this is coming under the category of super mesh problem. Why? Here you see we have 4 mesh. Current source is there in between 2 mesh. So these two form super mesh. Here also there is a dependent current source. This is the independent current source. Let us assume this is mesh 1, I1, right? This is mesh 2. Sorry, okay, let me assume this is right. Okay, I will start from here. This is I1. So mesh 1, mesh 2, mesh 3, mesh 4. Okay. So we have 4 mesh. Out of that we have 2 super mesh. So node 1 and node 2. I write properly. Node 1 and 2 form, sorry, mesh 1 and 2 form super mesh. Mesh 2 and 3 form a super mesh. So we have to connect all this. Whenever we have a super mesh like this, we have to go for a broader super mesh. So this is a super mesh. In between 1 and 2 we have super mesh. In between 2 and 3 also we have super mesh. So we collectively form a broad super mesh. Okay, this is 2. I2. Fine. Okay. Now what we have to do? We write supermesh equation. So KVL for supermesh 1, 2, and 3. Okay. How we are going to do? Whenever we write a KVL equation, what we do? We discard or just ignore supermesh branch. So we have to ignore this one and ignore this one. So here, what is the current? Let us start from here. Current flowing through this 1 ohm resistor is I1. So 1 into I1 plus here current flowing through this is in this resistor 2 into I2. The branch over here. So here it is 3 into I3 current coming in this direction. I4 current is in the opposite direction. So 3 into I3 minus I4. Now you come here. It is 7 I2. So this is a 7. So 7 I2 is equal to 0. Okay. So this is what we have written here, right? Now, next what we have to do, we have to write KCL for supermesh branch. So let us take this branch, right? So what is the thing? Here current is, I take this branch, so it is this one, 6 ampere. Here, take this side, here it is, I2 is coming, there I1 is going. So what happens? I2 is equal to 6 plus I1. Incoming current is equal to outgoing current. 6, this is I1. So like that we have to we have to write KVL for this mesh. So how can we write? Here you see, here I3 is coming, here I2 is going. So let us write this. This is like this. This is I3. This is I2. This is 3I0. Right? So what happens? I3. Right? So I3 is equal to 3. This is incoming. So I3 is equal to these two are incoming. So I3 plus 3I0 is equal to I2. Right? So we have written an equation. So this is equation number 1. This is equation number 2. Sorry, this is equal, not this is equation number 3, right? So next we have to write equation for mesh 4. So here what is the equation I can write? Current is 4I1, sorry 4I4. Then it is encountering positive terminal of the battery 5. So 4I4 plus 5 volt. Sorry, we don't need to write. And here the current going through this is I4. The current coming here is opposite direction I3. So 3 I4 minus I3 is equal to 0. How many variables? I1, I2, sorry, I1. This is I1, right? Okay. 1, 2, 3, 4, 4 variable, but sorry, 5 variable. So I1, 2, 3, 4 plus I0, 5 variable, but we have 4 equations. So we want 5 equation. What is another variable? I0. So I0, you see from here, we can say this is I0 current they have given in the problem. I0 is flowing in this direction. The current through this dependent source is depending on this I0. So from this, I can find one relation. I4 is equal to minus I0. That means I0 is equal to minus I4. Here you see, I4 is in this direction, I0 is opposite direction. So I0 is equal to minus I4. So now if I substitute I0 is equal to I4, we will have a 3 equation. So 4 equation. That is fine. Now substitute this one here. We will have 4 equation, 4 variable, and we can solve this problem, right? So in this way, we can write KVL equations for supermesh. I hope you understand all the 3 problems. you have any doubt, please ask me in comment section. I will clarify. Thank you.